Hello, nice to meet you. My name is Takeshi Kuwada. I work for iASYS Technology Solutions for business development in Japan. I worked with a customer from a major Japanese vehicle maker to create a test data management system that is used in vehicle development. And yes, this system uses graph database. We have been creating and operating the system together with our customer for the past 10 years. Today, I will talk about that system and how the graph can help vehicle development. When developing a vehicle, OEM does a lot of tests. For example, the power output test to know the acceleration speed, durability test to know whether it will not be damaged after many years. And the power data, durability data taken in these tests are very variable because they show the performance of the vehicle itself. Test data is originally used by many people. However, in many organizations, it is stored in a way that is very difficult to use. Why is that? Why does such a variable data stay hidden away from engineers? The reason is that vehicle development is very complicated process with many groups and people working together. So, let me tell you about one example. The case of a typical vehicle maker. They sell vehicles to various countries such as USA, Europe, China, India, and Japan. There are about 20 models for worldwide, including SUVs, sedans, and sports cars. Each model will be remodeled in 5 or 6 years. At the time of remodeling, development is divided into various phases from the concept phase to pre-mass production phase. In each phase, functions are designed and validation tests are performed using simulations and prototypes to meet the needs of customers. In addition, the development team is divided into groups for subsystems such as engine, battery, motor, and chassis. And among them, validation is performed on various evaluation parameters such as performance, durability, emissions, and noise vibration. And yes, the test is performed in various forms such as a simulation test, a component unit test, and an actual vehicle test. As you can see, in vehicle development, many types of information are used in a complex combination. In addition, there are so many departments and groups in the company, and so many people are involved to make one vehicle. Our BRICS PVM solution faces these challenges. We faced this challenge with the graph database and a global standard called ASAM ODS. Now let's see how the graph helps the product development. We have mapped the development process to graph database. Here is a diagram of BRICS PVM data model. This diagram shows node and relationships in a graph database. The model is classified into 6 groups. First group, a business group that contains information such as the sales country, model year, and so on. Second group, development target group that contains system code such as model code, project code, and so on. Third group, test target group, that contains information of unit under test, such as the prototype number, parts number, and so on. Fourth group, test plan group, that contains test information, such as test name, test type, and so on. Fifth group, functional requirement group. Sixth group, measurement group, that contains measurement data. Okay, these data were partially used depending on the department or group. In this data model, those data can be combined into one and linked to test data. Therefore, computers can understand the meaning. For example, the following context is well explained in this model. We are developing a 2020 model ABC vehicle for the United States. A prototype of the battery is created and a performance test is conducted. The functional requirement number is 123. It can also represent system relationships. We develop powertrain for EV. Project code is ABC. And powertrain model code is AAA. The model code of the motor, which is a subsystem, is XYZ. The model code of the battery, which is a subsystem, is HIJ. And the prototype hardware number used in the battery test is 345, and the software number is 678. In this way, the world of engineering can be properly mapped into the digital space. Engineers can be connected to each other through these data models. For example, hardware designers can search for test data by parts number. You can also understand which vehicle uses this part. Software designers can search for test data by software number. Business strategy engineers can see data for many vehicles from the project code. You can also see the data at different system levels. You can see vehicle performance data at the system level, or you can see powertrain data at the subsystem level. You can also see component level data. In this way, engineers can quickly find and understand the data they need for development. In fact, this model has another important secret. That engineering knowledge in the engineer's brain can be stored as a graph data model. Engineers create new data every day based on some data. A simple example would be to use engine data to simulate the output of a vehicle. Another example, we use data from multiple subsystems to calculate the performance of the powertrain. These are described as the relationship between such input data and output data. We also create a GUI for human users. This product can achieve data-oriented automation of the process. If you want to know more, please check our seminar video on YouTube. I explain more detail about this system. Please don't miss it.
iASYS. Connected research and engineering with connected data.